So this is going to be the first one in a series of webinars that we intend to start, depending on how is the receptivity from the audience side. So we thought that we'll begin with something which is a burning topic in the country today with whatever has happened around us. So we thought that setting the tone for a safe and secure hospital. So there was a India Fire and Security Yatra which is going on, and it is rotating through cities, and that is where I got the opportunity of understanding the importance of this topic. And it was around the same time that we had some fire problem in Rajasthan. And so we got intrigued to understand a little bit more about it. In fact, we even traveled there, to see what had happened and how one can probably prevent this in future. So that's how we thought that the first topic we will take is something which is to do with safe and secure hospital. Uh, so it was quite surprising to us when we went in did some dug up some research that it is pretty common to have fire in hospitals. There have been about 39 major fire incidents in hospital itself between 2025 and 2020, resulting in 153 deaths. In terms of compliance, this was a shocking finding. Of course, we come from Maharashtra, so we had more data around Maharashtra that 90% of Maharashtra hospitals lacked fire NOC. That was quite a jolt, that one understood. So, whosoever is in the audience from a hospital background should probably try and see if we have become compliant, over a period of time. It also came up in picture when the pandemic came, because oxygen enriched ICUs had some problems of fire. There were plenty of them throughout the country. Private hospitals are more at a risk because they are more electrical load heavy. Okay, so that is why it is important for private hospitals to be more fire safe. 78 to 95% of these fires are due to electrical short circuit. That is something which again jolted us, that this is a singular problem, and if we all work together and understand why this happens, then probably we should come out of this kind of a situation. So here are some of the names, and what is important for you to note here is that most of the times, if you read, the cause was short circuit. All right. And most of it happened in and around some critical areas. So it was ICUs, NICUs, COVID ICU again, so except one or two in Kanpur in Institute of Cardiology, where it was in storeroom short circuit, where probably there was inflammable material. Similarly, in AMRI in Kolkata, it was probably in a storeroom. But rest all of them, were in a critical care kind of a area. So where the problem is even acute, because you are dealing with people who are non-ambulatory, they are bedridden. So if something like this happens, it becomes difficult to evacuate them, right? And if you look at the 2022 column, you see general overheating, and because of which there was short circuit. So this has been a very common finding, which is coming up after whatever research we have done in the past 2 to 3 months, that this overheating is becoming an issue. So when we come further, I will ask my colleague also to chip in about this in a little bit more detail. Look at a global level. India has a fair bit of share in the global hospital fires, but if you look at the column 3, number of fire incidents, I'm talking of incidents, are more actually in United States, but there is no loss of life. Loss of life is very low. Whereas in India, the incidents are less, but loss of life is more. I mean, you look at the column 2 at the bottom, Delhi alone had about 66 incidents in 1 year. So that is something that we should not be proud of. And going forward, we should look at how to try and not let this happen. So let us understand some of the root causes. Like I said, oxygen rich environments, which are like ICUs, OTs, and ICUs, are one of the key areas where this happens. the oxygen makes the ordinary materials also combustible, leaks from pipelines or valves near ignition sources, and sparks from electrical equipment or wiring faults. Okay, so this is something which is a problem, and this leaks from pipelines or walls near ignition sources also is an issue. One should go for a good quality material when we are seeking, not to look at cost cutting, especially in areas where you have intensive care and critical care. Okay, continuous electrical load and infrastructure stress, and that is what actually is the 85%, 90% cause. So 24/7 load, because we are a building which operates 365 days, 24 hours throughout. So there is a air conditioning system which keeps working, there are ventilators in ICUs, monitors, which all causes overheating, and the aging wiring, poor earthing, degraded insulation, oversized demand on old UPS inverter systems. So these are the kind of things, which are there. So Satish, can you talk a little bit about, how does one go about, what precaution one should take in terms of wiring, especially and earthing?
Yes. So, as Dr. Desai has explained, that it is all 24 by 7 electrical load has to continue in the hospital because of the criticality. So when the load is 24 by 7, one has to take care of the electrical safety by taking a lot of safety factor. Like normally we take 20% safety factors. So whatever the kilowatt is there, no, for as per the kilowatt, there will be a full load ampere. So one has to take the ampere loading into consideration, and all the derating factors for all the wires and switch breakers has to be there, while designing the especially the medical equipment power supply and the HVAC power supply. So when you take derating factors into consideration, it includes all the continuous, because the continuous load is happening, there will be a continuous heat generations over a period of time, wire gets deteriorated. So all these factors are considered, so that the short circuit etc will not happen.
So Satish, even for UPS inverter also one needs to oversize by a certain percentage.
For UPS inverter, normally we take 30 minutes of the backup supply for the power backup supply, because the
Okay.
UPS is there for when the raw power supply is not there, like the transformer goes off, or the normal power supply goes off. So that time the DG gets switched into for a supplying. So within that DG and transformer, the lag is there. So for that, the UPS inverter will take into picture. So that we normally take 30 minutes, 15 to 30 minutes is the switching period. Yeah.
Okay.
Yeah.
And this earthing, can you just elaborate anything about earthing?
Earthing, see, we should understand what is earthing first. So whenever, some, we call it as a body earthing. So all medical equipment, all the electrical equipments are earth. Earth means any phase which is any loose, any leak current which happens to any medical equipment. If it is touched to any of the surface, it will get short circuit, or somebody touches that equipment, they will get a shock. So that current gets earth to the earth pit directly.
Oh,
So for each and every medical equipment, we have a separate dedicated earthing. For HVAC, we have a separate dedicated earthing. So normally people, combine the earthing pits. So it should not be done. Each and every individual equipment should have a separate earthing for a safer controlling the earth leakages.
okay.
Yeah.
Then the third is, flammable material in clinical areas. So because we had, post-COVID, all of you, used sanitizers which has alcohol based. There are drapes, curtains, consumables, which are one-use kind of a consumables. Anesthetics amplifies fire because anesthesia gases are inflammable. Poor segregation of chemicals and non-retardant textiles. So, you should have a storage system which very clearly defines these kind of inflammable material to be segregated from non-inflammable materials, and they should be under lock and key as far as possible, to so that they are not exposed. No flame retardant compliance checks we do, actually, to be honest. You can check yourself. If you are from a hospital and registered, then you will yourself see that you haven't done this probably ever. Then the other major problem is, that non-ambulatory and immobile patients. So when you have a bedridden, ventilated patient, as we saw, more than 60% of the time the fire is in critical care. So this becomes a problem. And then the staff to patient ratio limits the evacuation. So there is a delay in which there is a loss of life. Because the patient is in an environment which is oxygen rich, he is on a bed which has probably inflammable material all around him. All right. So this kind of drills should be practiced on a frequency. We'll talk about this little later also. And one of the most other important problem is that our exits are not generally blocked, in the sense that fire exits, staircases and others, we try and tend to put some storage there, or wheelchairs or stretchers, or boxes of material. So that should also not be there. The AMRI loss of life mostly happened because of blocked exits rather than only smoke. Now, high risk functional areas like ICU, we have already spoken about that. Then HVAC and ductwork system, so the other problem, which we will talk with Satish also, and he will explain more about it, that smoke spreads through, unsealed ducts. And if there are no fire dampers, if there is a pressurization imbalance, or the filters are clogged, so all of these kind of things lead to spread of fire. Satish, would you like to talk about this a little bit, that what one should do to avoid this?
Yes, yes. So normally, if you see a largest, hospital, you will see a AHU system, air handling unit system, where it will be consisting of one air handling unit, and then there will be a supply duct and return duct. So air circulates through a supply duct and again return back to a AHU by means of return duct. So it goes on in a normal condition, but when a fire happens and a smoke gets generated, what happens if the AHU is switched on till into that particular period? Then the smoke gets sprayed and circulated inside all the spaces via AHU. So one has to put a fire damper in the supply duct as well as a return duct. So what happens when the fire gets detected? Fire alarm panel send a signal to the AHU panel and the respective fire damper to cut off. So the starter panel of the AHU gets a signal from fire alarm panel to get off. So AHU motor uh, gets tripped, and in parallelly, the fire damper which is mounted in the supply and return duct gets off. So because of this isolations or at the duct, both the ducts, the smoke doesn't spread into the premises. That is the key during the fire exhaust system. Apart from that, here you have stopped the circulations of the smoke inside the premises, and another system is a smoke exhaust system, which is a separate system. There you will have a smoke exhaust fan either mounted outside or on the terrace level, and it will be connected by means of a smoke exhaust duct. So whenever the occupants are passing through a fire escape path, so we have a smoke duct into the passages above the false ceiling. So smoke gets sucked from the escape passages and it gets exhaust out to atmosphere, so that occupants get a clear smoke-free environment while escaping out from the area. That is one thing. And also now, nowadays, CFO also insists for a makeup air. So the idea is that the makeup air has to supply from the bottom level, like from the up to the 1 feet level, so that whenever occupants are passing through a escape passage, they get a oxygen. Because in the smoke, everybody knows that it generates a carbon monoxide and carbon dioxide. So it gets suffocation problems while escaping out. So idea is to provide oxygen from the bottom, so that people can easily go through the smoke area and get out from the building. But here another contradictory thing is that it completes a fire triangle. When you supply a makeup air, means you are supplying a fresh air, it gives a oxygen, so it tends to spread more fire. So that's one contradictory thing is in discussion with CFO.
But do we do this now, or it is not practiced?
Yeah, we do this for all the hospitals now. It is compulsory and we are maintaining it. So
I see.
yeah.
Okay. Okay, okay. Then, I mean, that is interesting. I didn't know that you have to supply from the bottom. Okay. Then the last point here is human error and system negligence. This is happening because we defer maintenance. It's a very common practice, even in our offices, probably we don't do it. There is untrained staff, we don't take cognizance that people need to be trained. The extinguishers are expiry date, so we probably again, it's a human error. Renovations without permits or fire watch. So what Satish was explaining, that if you are doing some renovation, then you have to take care of this AHU, fire dampers, smoke exhaust systems, the fresh air to be ingressed during things. All these things need to be done. We probably don't do it because the building already has a occupancy certificate and no one bothers, to go back to get a permit for the same thing. So this is not there in hospitals abroad. So that is one of the prime reasons where incidences of fire in United States probably are quite high, but the death, or injury, major injury is not there, because they probably follow this more strictly, than we do. Then missing NOCs, there are fake compliance certificates. This is something that we have to take it upon ourselves not to indulge in, some kind of a thing which is wrong. All right. Then fire protection system wise, there are two strategies that one has, passive fire protection and the active fire protection. So passive, it means it contains the fire and smoke. Okay, what Satish was mentioning, enables defense in place in terms of the sprinkler, protects it, 24/7 without power. Structural integrity is important. So fire rating of walls and glass and other things is important. So, it's not only, I mean, if you create a building with too much of glass, so Satish will tell you that, too much of glass also, the glass becomes hot, and then it may actually splinter, and then you may get hurt by the shards of the glass. So Satish, how do you tackle that?
Yeah, that's correct. So because of the smoke contains, certain high temperatures. So what happens, people normally have a longer facades with a glass, with a, aesthetic. It looks aesthetically good, but what happens when you have a high length glasses, and whenever the fire is caught, smoke spreads, and smoke has a temperature. It transfer heat to the glass, and glass has certain, withstanding temperature. So after a particular temperature, glass will break. So what we do normally for all that facades and especially the windows, we have a curtain sprinklers. So it's a glass curtain sprinklers. So whenever the fire is caught and smoke is spread, the fire alarm gets, gives signal to the deluge wall, and deluge wall is connected to this fire curtain, this glass curtain sprinklers. So the sprinkler, it will form, as the name indicates, it will form a curtain of the water over the glass like a water fountain, and it will cool the glass so that it should not break due to the heat.
Got that.
Yeah.
Thank you. So passive, compartmentalization. So there are certain NBC norms. We'll talk about that, later also. There are fire rated walls with 2 hours minimum, is what the NBC says. Fire rated doors, fire rated glass that we use. Then vertical protections. You need to seal the shaft, so that the smoke doesn't spread. The death in fire actually is not so much because of burns, it is more because of inhalation of carbon monoxide, is the major cause. So you have to, seal the shaft so that fire doesn't travel, what he was saying in terms of dampers, in air handling units. Then the cable risers should have, so because electrical wires also will take the fire, so all those should be maintained as per the NBC Part 4 National Building Code. Material and fire stops, fire rated sealants, barriers, dampers, signage and visibility. This is one of the problem otherwise, that you may not know where to run, in case of fire. So it should have a luminous exit signs, on floors which are there. In terms of active, measures is simple. It's detect, warn, and suppress. So it will detect, it will automatically operate the sprinkler systems provided they are maintained. So that is something which I am keep on harping. Detection and alarms, sprinkler hydrants, fire pumps and water supply, you should install and maintain. I am again underlining the word maintain. We don't, so there was a recent fire somewhere in Mumbai about 3 days back. and the fire hose didn't work only. It was in a tall tower, which happened. You had recently, you must have read in Hong Kong, one of the more developed kind of a city, there were 120 deaths in a housing residential area because it was not maintained properly. So those kind of things we have to be extremely careful, especially if you are going on a high rise kind of building, which is what hospitals are probably trying to do. Uh, there is one more kind of a system which has come of late, and there are some hospitals in Gujarat which have tried them out, and it is called a water mist fire protection system, So the purpose is that because of the fine droplets, they are able to absorb the heat and thereby displace oxygen, achieving suppression with minimum water damage. So water damage in the sense, the water when it sprinkles will damage, the equipment and the other thing which are there, so that would get minimized. This is like a mist, so it is not going to wet the surface which is there, and it is ideal for sensitive medical environments. I think, if I'm not mistaken, Zydus Hospital in Ahmedabad and some government hospitals in Ahmedabad have started to use this, after CFOs of those states have approved them, for usage. So, and it can be pretty useful in sensitive areas, especially. Plus, the other advantage is you don't need that, large water tank capacity to fight fire. If you are able to do this using a mist kind of a system, which rapidly cools, reduces the collateral damage and is environmental friendly because it uses, less water. Okay, so you can use this in some operating rooms and ICUs where otherwise we don't use, firefighting systems. So this is a new kind of a system which one can look at. Now, some of the NBC 2016 Part 4, hospital requirements, because hospitals fall under Group C1 institution, hospitals, sanatoriums, nursing homes, and all of that. One of the important points there, which is becoming a bit of a problem for the private sector as well as government, is the limitation of height. So what is today prescribed is that we cannot have critical and non-ambulatory patients more than 30 meters of height. So hospitals itself, they've capped at 30 meters. That becomes a problem, especially if you are in a city like Bombay, or in any city where land is precious and you cannot go tall. So that becomes a problem. So there is a move to try and increase this height in the NBC itself, and also through Bureau of Indian Standards. HOSMAC has also been part of this, in terms of creating a document presented to the Ministry of Health, through an organization called Nat Health, which is a forum and federation of healthcare providers, medical equipment vendors, insurance companies, and all of that. So we are trying to see we can, go beyond this 30-meter. So, for example, in city of Mumbai, I am allowed a height of 70 meters, because we have scarcity of land. And but here the norm is that you cannot take critical care beyond 45 meters rather than 30. So there is some relaxation here. In Telangana, they have allowed hospitals now to go up to 120 meters. Okay, so one of the things that here happens is this: the tallness is not only because of how you fight fire, but it is also to do with how you rescue patients. So most of the snorkels in cities or municipalities across India do not have snorkels which go beyond 30 meters. That is one of the reasons why it has been pegged at 30. So Bombay has recently gone and bought something which allows the snorkel to go up to 70 or 90 meters, something like that. It's a fairly expensive equipment, 8 crores. But because of that, the advantage is that we are allowed now to go up to that height in city of Bombay. So these are some things that some other states and cities can also look at, and we can follow that. Then there are certain basement restrictions. I think this we should follow religiously. No inflammable or chemical storage in basement, because if it goes, if it burns, then there is a problem. All staircases should be 120 minute, protection, opening directly to the open air when you go through, basement up. Fire resistance in terms of structural ratings, so Load-bearing walls 120 to 240 meters. Fire exits and shafts and staircases 120-minute fire rating. Compartment walls, 2-hour separation rating. Limit the area of each compartment typically to 750 for C1 occupancy. This was actually earlier 500 square meters, but if you are a completely sprinkled and fire detected kind of a safe building, they allow you to go 50% more. So, that kind of compartmentalization is allowed. Uh, then in terms of vertical circulation, if a building is more than 45 meters, and there are a lot of hospitals now which are going more than 45 meters in various cities, then there is a fireman lift mandatory. That you need to have a lift which will be used only by the firemen, at a certain a positive pressure. Satish, can you talk about that? I don't know this 25-30 PA positive pressure.
Yeah, yeah. So lift lobby has to be maintained at 30 Pascal pressure, whereas all the staircases, all the lift pit and the lift well has to be maintained for the 50 Pascal. So that the idea is simple, that when you have a positive pressure inside the lift well, if people are traveling during the fire escape, the smoke will not travel into the lift car. That's the reason. And also the staircases has to be positively pressurized, because it's a escape path. The smoke should not come from the premises into the staircase. That's the idea for keeping the positive pressure during the fire emergency.
Got that. Thank you. Then there are some egress and evacuation provisions. Corridor width should be 2.4 meters clear. It should be clear height of 2.4 meters. There should be no column coming in between that 2.4 meter, unobstructed. Exit doors, 1.25 meter minimum width for single double rooms. If it is 3 to 5 bed wards, then 1.5, and larger wards than 2 meters. So we usually try and keep general wards also 2 meters when we design hospitals, because it needs a little bit larger aperture. There are some stipulations around internal staircases can be less than 2 meters, but when we design, we usually insist on 2 meters all over, because if you have to use staircases for evacuation, then it's better to have a wider staircase. You go to any Apollo hospital, you will find, stretchers which are able to go down a staircase, and they are stacked near the landing, in all Apollo hospitals pan India. So those kind of things, one should not cut corner. It's a small point 0.5 meter more wider staircase, and that will work for us. Travel distances is always been a debatable subject. So but the NBC allows about 45 to 60 meters in a fully sprinkled pressurized hospital buildings. Okay, maximum is 60, but try not to keep it to 60. 45 is what one should look at, kind of thing. In fact, many towns insist on 30 meters. So try and keep it 45 at least. 60 is a bit though it is allowed. Okay. In terms of compartmentation, 500 square meters per fire compartment. Inpatient floor should be divided at least into 2 smoke zones for horizontal evacuation. Critical care zones, should be enclosed by 120-minute barrier. Fire stopping for shaft ducts. We've already, mentioned that. Smoke management, he just mentioned about that, 25 Pascal to 50 Pascal in the lift shaft. HVAC and ventilation, because now, so this HVAC is one of the key criteria to fight fire in a proper way, and this should not go wrong, because most hospitals now are becoming centrally air conditioned, including those owned by the government. So all AIMS are centrally air conditioned. So you should have fire dampers and all of that he mentioned should be there. In basements, mechanical extract more than 30 air changes per hour, non-combustible filters. Is there anything you want to talk about basement exhaust, Satish?
Yeah. So basement exhaust now, I think it is revised to 12 ACPH, not 30.
Okay.
So it has to be there for basement. Normally, again, there will be a smoke exhaust systems at 12 ACPH, and the fresher also required as a fresher makeup for supplying oxygen to occupants.
Okay.
And yeah, and normally normally CFO keeps on asking, despite of giving a mechanical ventilation, they keeps on asking, giving a natural pressure also, uh, around 10 to 20% pressure has to be supplied naturally, so that one has to keep a continuous open shaft for a basement. So that normally they insist, despite the mechanical ventilation is provided.
Got that.
Yeah.
Okay. Then active fire protection, system sprinklers, we already know. Hydrant, wet riser network, more than 100 hose reels, downcomers at each floor, portable fire extinguishers, alternate power supply for all firefighting, systems in terms of pumps, alarms, and pressurization and fans. Access and service provisions. Fire. So this is another important design criteria, for planning hospitals. The fire tender approach 6 meter wide road, 4.5 meter entrance, 5 meter headroom. This is minimum, which is required. It also needs a turning radius of 9 meter, minimum. So this is something that we go wrong. So we do a 6 meter, all around the building, but we forget that it needs 9 meters to turn at the corner. So that needs to be, planned properly. Otherwise, the fire engine will find it very difficult to go around. Okay. So this is something that one needs to, keep in mind. Then there are certain Bureau of Indian Standards, which are there. There are codes which are given here. Smoke detector. So Satish, how what should be the frequency? So this is correct, 7.5 meter.
Yeah, that is correct. It's a normal range, but it's normally designed on a coverage area. So the coverage area has to be calculated, and accordingly, the smoke detector should be spaced out. But normally, it comes to around 7 to 7.5 meter.
Okay, and heat detector should be 5.3. That's the
Yeah,
utility
yeah, that is
system.
true. Yeah.
Okay, okay. And then manual call point at every 30 meters, alarm loudness also have certain decibels so that people hear it properly. And the most important is quarterly testing and maintenance mandatory. This is something that we probably miss. Then there is fire extinguishers, depending on the area, again, the travel distances and all of that. CO2 clean agent units for OT, ICUs, all of that. Monthly visual checks, quarterly detailed servicing. This is again, so we should try and use that airline method, where they have a tick mark. So many of the toilets you go in airports, there is that, chart where, one has to tick mark whether he's cleaned it or not, So something similar should be done for this detailed servicing and followed religiously, if we have to keep our hospitals as safe and secure. Okay. Then, in general, I think electrical installation and fire safety is something which is important. So, using rigid steel conduits, armored cables, fire pump via direct feeder, 150% overload margin. Anything you want to talk about this, Satish, in terms of because this is also some areas where clients tend to cut cost.
Yeah, right, right. So MS conduits are normally preferred because it doesn't get melted during fire because of the high smoke temperatures. But people normally uses PVC conduit. So if they use a PVC conduit, they has to use it FRLS grade or the HMS grade conduits. But MS conduit is preferable. At the same time, armored cables are also has to be ZHFR. Nowadays they are asking a ZSFR, zero halogen free, and smoke resistance cables, so that has to be used throughout the hospitals. And the fire pump, when we design it, no, the criteria is that it should take a 150% of the water load. So when the pump is operated, so it should not get failed when the multiple outlets are being used by the fire officer. So, and because if the overload, because of overload, the fire pump will get trip or burn. So that's the criteria, that it should be consider 150% overload margin. And
Got that.
just one thing I wanted to add in the first column, fire detection and alarm system, where there is a noisy area in the hospital, sir. If the alarm, the alarms are will not be possible to hear, so strobe lights are used. So strobe lights are nothing but it's a flashes. Whenever the fire is caught, it flashes light, so that it can be very easily visually seen.
Understood. Satish, can you tell us that, the PVC coating versus the steel or ZFHR, whatever you were saying, what's the cost differential?
MS conduits will be costlier, sir, around maybe 30 to 40% higher as compared to PVC conduits.
Okay. And that ZF, what we were talking about,
That is also 20%, 20 to 25% higher than a normal cable.
right, right.
Zero halogen and yeah, smoke free.
Got that. So, guys, this is important to understand because wiring is one of the most extensively used material, in hospitals, and people tend to save cost here. So, you should make that balance of, where to stop cutting cost and where to be, be serious. So, I would suggest that no compromise in critical care, areas, or for better word is, wherever you have electrical overload kind of areas, go for wiring which is, safe, so that we don't
And
make
what
any.
happens, sir, when wiring gets burned, it generates more smoke and more carbon dioxide.
Right.
That's the thing is taken care here by giving the fire retardant and low smoke cables.
Understood. Understood. Then, there are certain norms about the internal fire hydrants and water storage of all of that. So hospitals which are less than 24-meter height need minimum 150,000 liters, of water. And then there are other norms which will go beyond. 63 landing walls, etc., wet risers, it should be always charged, so anything around that, Satish, that, how do we keep that always charged?
Yeah, so first thing regarding the water tanks, whenever there is a larger spread hospital, so fire NBC has a norms that if the fire hydrants quantity is more than 100 numbers, one has to double the capacity of the fire tank. So here it is suppose 150 kl is required, so you'll have to double it. So 300 kl tank is to be given, and the diesel pump set has to be increased. So capacity for a larger hospital normally it goes 4 to 5 lakhs liters of water for a fire storage tanks. And the weight riser means it has to be always charged. The pump has to be always into operation. And there is a jockey pump which keeps on hunting. Like whenever the pressure drops, like suppose any leakage happens, the jockey pump will automatically start to maintain the pressure of 7.5 kg in the fire water system. So normally, if you see, everywhere in the all the buildings, all the hospital buildings, people will put pump off, and it will not be weight riser. It will be a dry risers. Weight means the water has to be filled into the entire system from pump up to the terminal points of the sprinkler and hydrant. So normally people don't do that. So idea is that if it is a dry riser and the fire is caught, it will take some time to reach the water up to that fire space. So because of that, it has to be always weight riser and the system has to be always pressurized so that the fire is caught. Immediately the water will come out and sprinkle and extinguish the fire.
What is the CFO norm, Satish?
CFO norm is the same, sir. They want 3.5 kg pressure
No,
to be.
no, they insist on wet or dry is also allowed.
It is weight riser, weight riser. So
They
dry
insist.
riser is normally taken in the very, very cold country
Okay,
because the water tends to get frozen because of the low temperature.
okay,
So dry riser is used there, but even if it is a dry riser, it will be filled with the nitrogen gas first, and then the water will come.
okay.
That's the idea actually. It's not applicable here for the non-cold countries.
Understood. Thank you. There are certain, NABH and JCI requirements as well, so I will go for, the one which are in yellow thing. So fully functional and tested regularly, put your hand to your chest and say whether you really do this or not. Detection and alarm center, alarm standards across all zones 24/7. Mock drills and staff training. There is a race protocol, rescue alarm, confine, extinguish, implemented hospital wide, and quarterly drills are mandatory. Quarterly drills are mandatory. I don't know how many of us do that. Then there should be no obstruction at the egress point. So, people when they are running out, should be able to run out smoothly. Maintenance and audits, there should be scheduled audits, logbooks for fire system testing and corrective action tracking. And logbook should be, not just filled in, it should actually be done. All right, and there should be documentation, for NABH for that matter. In terms of Joint Commission International, most of it is similar, but they have a four-phase emergency cycle: mitigation, preparedness, response, recovery. Okay, and they have a RACE plus HICS. HICS is Hospital Incident Command System. So they are more, and that is one of the reasons why, whenever fire happens there, damage is minimal. You can look at that quarterly fire drills per shift, so we don't do that per shift in India. It should be done per shift. Okay, so that is something which is important. And I think, a third party probably, in the conference also that I went for, this FSAI conference in India Fire and Safety Security Yatra. This was one of the point, that because CFO offices cannot, do not have that kind of a human resource to do this, so we should probably have a third party check. We should, identify certain, firms which can do this, and we should probably give this as a third party kind of audit. uh, So something about the evacuation planning. So, there should be a progressive evacuation, strategy. Move patients to adjacent smoke compartments on the same floor, so that, we are able to take them either through the staircases or bring them to a refuge floor from where a fire engine snorkel can pick them up. Or if any of your elevators is fire rated, CFOs. So one of the things that we are recommending, that if you go taller beyond say 65 meters, each of the elevator banks should have a fire rated elevator. If you go to Singapore, every bank will have, such elevators which can be used during a fire for up to an hour or whatever is the rating, of that. So something like that, we should also try to insist. We should enable continuum of care, because, if the person is on ventilator or all, so those kind of thing, should be. So if you look at Reliance Foundation Hospital in Bombay, they have created a fire corridor at the rear side of the hospital, which is a completely safe fire, kind of a route, which takes you to a staircase and elevator core, which can be used during fire. Okay. And then fire rated doors, auto close on these are all things that we need to do. Vertical evacuation used only when fire smoke breaches the floor zone, and you can't, then move horizontally. Then you have to, through protected staircases or elevators, like I mentioned, we can do. Then there is a patient prioritization, ambulatory and children to be, knocked out first. Then wheelchair limited mobility, wheelchairs, walkers, evacuation chairs are now available, which can go down a staircase actually. So the society where I stay, it's a 45-story building. You have a wheelchair which can go down a staircase, which is meant. Monitored patient on a bed or a stretcher to be taken down, then we need batteries, because you have to monitor the patient as well, and also oxygen cylinder, which needs to be taken below the bed. So all those, things have to be in place. That is why they don't allow more than 30 meters for critical care, which probably one can follow. But ambulatory and non-critical patients probably should be allowed beyond 45 meters with proper, what you call, evacuation system and firefighting systems which is there. But the most important is the protocol and training techniques. The staff trainers, higher annual refresher. You can There are companies which provide you, this kind of a thing. We should do that. There should be competency tests. You can give certificates to employers, employees who do that. Then there is a pass technique. Satish will explain to you. If you don't do it well, Satish, what happens?
What's that, sir? Uh,
Pass technique, pull, aim, squeeze, sweep.
yeah. Regarding that is regarding the fire extinguisher. So the pass technique is pull, like see, if you see the fire extinguishers, it is clamped with some clip. So you have to pull that clip, and then aim means where the fire is caught, that base you have to aim. And then squeeze means you have to just press that knob, so that when you press that knob, the seal inside that fire extinguisher gets broken, and from there the carbon dioxide and the particular powder gets released, and then you have to sweep it. Sweep means you will have to just spray the hose, so that equally that gases and the powder will spread over the fire surface, and it will get extinguished.
Right. So if you're not trained, you end up, when you squeeze, the thing comes on your face. So you need to be properly trained, to see that when you are squeezing, the direction of that extinguisher is toward the fire and
Yeah.
not towards your own face.
If that hose, the wall is off, and you are squeezing that fire extinguisher's seal, then the entire pressure will come onto your face. So
Correct.
that's the reason. So you'll have to just open it and then spread it. So that's why the proper training has to be taken by
Right.
every. Yeah.
Right. Okay. Uh, so then the audits and compliance governance, so you can look at we in Maharashtra I'm talking about because we have some data around there. So in Nagpur alone, 65% hospitals lacked valid fire NOC. Pune only 10.2% hospital had a fire clearance. And again in 22, 4.2% of government hospital had fire NOC. So this is the kind of affair that we are in, and we need to rise up from here to make ourselves more safe and more secure, kind of a thing. So like I said earlier, third party check is probably a good thing. Quarterly critical equipment checks, visual inspections, all components to be checked. So it is not only the fire protection system but also the building infrastructure itself. If it is aging, if your wiring is bad, if your air conditioning systems are overused, and they have lived beyond their thing, you should change. So all those high risk area evaluations, one need to do that and focus on the high risk areas, because we know now that short circuit is the major problem, critical care areas are the major problem, kitchen is the major problem, laboratories where we store chemicals which are inflammable are the problem. So make at least those areas more secure in terms of the wiring, in terms of the firefighting equipment in and around that, the sprinkler system, detector systems, all of that. Okay. uh, Now, this I have already spoken about. This is just taking it into a snapshot. We can share this, the presentation with you, so should not be a problem. So all those compliances, needs to be managed properly. That is the key thing which is there. And like in the electrical safety, the yellow point is 30%. He mentioned the 20% safety margin. What the standard says, globally is 30% safety margin. Now, this is something where the client needs to be educated. They generally don't like to do that because it's a cost, factor for them, right? But fire resistance cables, are important, like he explained to you. So all of those are things which one should follow very strictly. Okay. All regulatory compliances should be in place, fire NOC, BIS certification, third party audits, municipal approval, yes or no. All right. So all of those things which are there. Then something for existing hospital facilities, the gap analysis. So we should, whatever we have learned today, we should just do a gap analysis of where we are, as compared to what is required, and then prioritize, the life safety issues in terms of mostly electrical, short circuit areas. Please do check, evacuate, any egress point blockages, all of that. Equipment system and upgrades wherever required, install addressable alarms, retrofit sprinklers wherever required, start with critical areas to begin with, and then slowly, because everything costs money. So I have seen a lot of hospitals which have exposed firefighting system. No problem, you can do that as well. Safety is more important than aesthetics at some point in time. Okay. Then electrical and building safety, we've already spoken about that. Fire pump, he's already spoken about that. And then governance and training, you should have one fire safety officer if your hospital is 100 bed plus, so that he is the guy who keeps this, mock drills and training materials, all of those can be done now with digital medium. It is easier to train your people, it is easier to keep campaigning, that we need to do this. So it's much easier than what it used to be earlier. I think the last slide, some food for thought. Should glass facades in critical areas be limited or substituted with fire rated panels? So, Satish has already, talked about how you have that curtain fountain, kind of a thing wherever you have high glass. So, we've kept here a building which has a lot of glass, so we have suggested, to do that in this building. Uh, Fire dampers, Satish has already spoken about. And Satish, one quick question, between split or ductable HVAC with chillers, which is the preferred system from a fire perspective?
Uh, so for from a fire perspective, basically it won't matter, sir, either it is a split or AHO, because fire fighting will have a separate system for exhausting and supplying the fresh air during fire. So it won't do as such. Like even if I put a split, I have to use a smoke exhaust system.
Okay.
Yeah.
Got it. Got it. Got it. Got it. Okay. Then the last point, Satish, again is for you, that should return air ducting be mandatory? So this is something we are having some problem in some cases where CFOs, say that return air ducting should be mandatory. And it becomes difficult because, of the height restriction of the building. We are not allowed to have flat slabs. So we have a beam, below which the thing goes, you know. So what is your take on this? Should it be mandatory or, should it be discretionary?
It should be discretionary actually, because it will, if you have a return deducting for each and every department and sectors, then definitely it will be more congestion above the fall ceiling. So what we normally do for a hospital for a critical areas like OTs, ICUs, we try to put a return air duct, and the rest of the areas will be above fall ceiling. Because on the other hand side, for a safety perspective, we also have a smoke exhaust and a fresh air makeup system to take, and also the fire dampers. So it normally will not do as such if we don't provide return air duct everywhere.
Okay. All right. So, guys, thank you. We are done. If there are any questions, please feel free to, ask us. Our email IDs are given there. So, you can write to us as well.